Assalamu alaikum. I hope everyone is doing fine. So, for those who have never attended my lecture, this is Ferial Al-Ghafrini, and I'm giving lectures related to industrial electricity. Together, we did two chapters. The first chapter was related to electricity, and the second chapter was related to magnetism. And in this chapter, we'll discover and explore a key topic, okay, in industrial electricity, which is electrical transformer. So, previously we said that there's different kind of power sources uh, of and energies. Okay, for example, there is renewable, there is conventional, etc. And the goal of such power and the goal of such energy and the goal of such power stations is to produce electricity. Okay, but there is a problem. In general, power stations are located far away from cities. Okay, where electricity is consumed. The cities have factories, have residential buildings, they have schools, and this is the real consumers. But they are located far away from power stations. Okay, we can take the example of solar power stations, which are located in desert area, while the consumers are generally located in the north. Okay, or here or another example, if we are producing here, it is a national grid, electrical grid. Ok, mais c'est une version un peu ancienne. If we, for example, if you have here the power plants of Shershel, which is located in Hajat al-Nas, it is connected. The electrical wires are connected to Blida, and they are also as well connected to Medea. For example, they are connected to Ain Ussar. You can imagine the distance that electricity uh, is transferring to. So, uh, so producing electricity is not enough. We need to produce electricity and transfer electricity. Okay, because the consumers are in most cases located far away from the producers. Okay, and this is one example cases, and we have also sometimes regions that are located in extremely distant area. For example, we have the cables, we have the electrical wires that are shared between Tunisia and Algeria. Imagine that here in Algeria we are producing electricity which is consumed in Tunisia or which is consumed in Morocco. This is both strange and mysterious. How can electricity be produced here in Algeria but it is consumed in Morocco or in Tunisia? Okay, actually, it is something that can be achieved uh, by using transmission lines. Okay, by using transmission lines. So electricity should be transferred via long these transmission lines to attain these consumers. Okay, but this is not that easy. There is some problems. There is some difficulties that need to be discussed. In general, the generated electricity is typically at a low voltage, approximative to 1 kilovolt or 1,000 volt. Okay, and this low voltage is not suitable for long distance transmission. On ne peut pas faire de transmission à de très longue distance en utilisant la tension, la faible tension, la tension basse. Okay. So why? The question is why? Why we cannot do long distance transmission using low voltage? We have one simple rule, which is Joule's rule. Okay, previously done in this first chapter. This rule, what it states? It states that the power equals the voltage times to the current. Ok, la puissance est égale à la tension fois le courant. Donc, If I have a small voltage, if I have a small voltage, that means I have a big current. Okay, and be careful to a big current because I have a second law, which is called a power loss law. Okay, this power law, what it states that the current squared, le courant au carré, times the resistance fois la résistance. D'accord? So, if I have a big current, that means I have a big loss. Okay, that's why, yes, if I have more current, that means I have a big loss. Okay, and in general, this loss is dissipated in form of heat. يعني il y a un réchauffement de câblage, d'accord, et qui vont ensuite être perdus. Donc, if I have a small voltage, I have a big current. If I have a big current, that means I have a power loss. Okay, j'ai une perte d'énergie. Is that a good thing? No, of course, it's not a good thing. This is a bad. This is bad. Okay, why? Because I want to save as much electricity as possible. If I produce electricity, I want to save it and transfer it into the client or the consumer as it is. I don't want to waste my energy because if I waste my energy, it is a waste of resource and money. Okay, so what can we do in this case? I want to transmit my electricity into extremely distant area, but without any losses. As as loss depends on current, as we previously said, we can change the power. Okay, I can't change the power. I can't raise the power or decrease the power because the consumer needs a specified power. Okay, and this is the thing I want to deliver. I want exactly to deliver some precise amount of power. So I can't change the power, but we can change how we send it. Okay, and this is the key important thing that we can change. We can change how we send it. How? Again, using this relation. The power equals the voltage times 2 the current. Okay, the power equals the voltage times the current. Okay, so if we increase the voltage, si on augmente la tension, the current gets smaller. Le courant devient petit. Okay, and if I have a smaller current, that means I have few losses. Okay, here we take an example. If we want to send 1000 watts of power, we have two options. Okay, if the voltage, for example, is 10 volt, then the current will be 1000 ampere. That means I have a big current. That means big losses. Okay. The second scenario, if the voltage equals to 1000 volt, then the current equals to 1 amperes. Okay. In this case, I have small current. That means tiny losses. Okay. So all 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 is related to this ratio. Okay. Decreasing the voltage, increasing the current, increasing the voltage, decreasing the current. Okay, so this is not all. If we want, if we said that there is a production of electricity and there is an increase of voltage, okay, uh, to so we can be able to transfer our electricity without any loss. Okay, however, in our homes we cannot use such high level of voltage. Okay, I want to I use reduced in our homes. We use reduced voltage, so once again we need to reduce the voltage. Okay, so in the first step I need to a transformer to steps up voltage for transmission, and in the second step I need to a transformer that steps down the voltage. Okay, So how do power stations ensure such conversion? As we said, we need to use an electrical transformer. Okay, this electrical transformer is used here in green to stepping up the voltage, and then to step it down, and then to step it down. Okay. Yes, this is I think this is what is it related to transformer. So we'll continue in the next video. Okay.